Thank you. Thank you very much. Okay, thank you for coming back from lunch. I hope to keep you guys awake. Okay, so my name is Tal, and I hope you can see. So we will discuss in this lecture. I will demonstrate how we can use the insecurity of Bluetooth Smart to hack smartphones using the application level. We will briefly go over the Bluetooth security aspects, and then we will see how we can perform man-in-the-middle, active man-in-the-middle attack between the device to the app, the designated app or any app. And then we'll see a few tools and how we can tamper with the data or perform replay attack that eventually will perform actions on our smartphone. Okay, so my name is Tal. Been working in the InfoSec, cybersecurity, how you want to call it, for more than 12 years. Currently, I'm working with a few companies, AppSec Labs in Israel, CNAC, if you know, private bug bounty services, and FBK, she's a European research facility in Italy. I also established, besides Trento, we'll talk about it later. Previously, I've been working with RSA and Checkpoint, and you can follow me at my website, appsec.it, or my Twitter handle. Okay, let me just, can you see? Okay, let me just explain to you guys. So, just a few words about myself. So, I'm from Israel originally. Recently, I've moved to Trento, Italy, which is a very north city in Italy on the Dolomites, and I moved there because my wife, it is my wife's hometown, and we just had our first baby there, and so I thought Geneva and Trento, very close to each other, would be very easy to go here. So I thought, what would be the best solution to get there? It's a 1-hour flight if you measure the distance. So the problem was that Trento doesn't have an airport. So this plan went away. So I thought about, okay, next best solution would be one drive to Verona, which is 1 hour away from Trento, and then 1 hour flight to Geneva. But no direct flights from Verona to Geneva. Okay, what would be the second best, or the real possibilities? So what would have happened is that I planned to leave Trento to Verona and then take the flight from there with a connection flight and land in Geneva at 5 p.m. So 1 hour drive to Verona, 1 hour I gave myself a security gap for the security checks, check-in, and traffic possibilities. 1 hour flight to Frankfurt, 1 hour connection, and another hour flight to Geneva. Total time, 5.5 hours. Okay, it's not great, but it's not that bad. But what actually happened is that 11:30 a.m. I was leaving Trento. 1 hour later, I arrived at the Verona airport. Then, after doing the security checks, I realized I forgot my passport at home, and there was no way for me to go back and forth because I had no time left. So, I was thinking about the solution after trying to convince them to let me fly anyway, but it didn't work. So I was thinking, checking trains, everything. Nothing really came out great. At 2 p.m., I found a solution. I will go back to Trento, take my passport, get on a train to Verona. From Verona, I will go to Geneva, but the problem is it's a 7 hours train. Plus, it was late, so I arrived not at 11:30, but actually at 1 a.m. At the hotel. So instead of 1 hour flight, or which would be the best option, it took me more than 12 hours to get here, but I'm still here. Okay, I made everything to being. No, thank you, thank you. Made sure that you'll be able to see this this talk. Okay, so just short acknowledgements. So I've been doing this research at AppSec Labs. We specialize at AppSec. So IoT is one aspect of it, and we've been doing a lot of research in this field, and this is just part of it. I would also like to thank Slawomir, which is one of the pioneers of this field of the BLE security, which you can follow there. Okay, let's start. What is BLE? Shortcut for Bluetooth Low Energy, also called Bluetooth Smart, hence the title. It is part of Bluetooth 4.0. Okay, it is designed to be power efficient and smaller and cheaper. So now with the well, IoT now is everywhere. I'm pretty sure that half of you wear something that is related to IoT. So it's designed to be smaller, more efficient, low cost, so we can actually start developing a lot of stuff using BLE. We can find it everywhere, of course, wearables, watches, and then at home, smart homes, light bulbs, smart plugs, medical devices, any other thing that you can think of. Okay, what is the difference between Bluetooth Classic, the original Bluetooth that we know, and BLE? So they're totally different. They cannot talk with each other. It's a different protocol. They have different architecture, different modulation, different channels, different packet formats, etc., etc. So when we talk about BLE, it's actually Bluetooth, but it's a different protocol. So it's not compatible. It's not backward compatible. Okay, so where is the risk? Is everywhere actually. So just probably seen a lot lately with smart locks. There are many smart locks with Bluetooth that based on Bluetooth. Most of them don't work well. I mean, they work, but not security-wise. And if they are locks and they're not working security-wise well, then they are not actually working. So most of the locks, I'm not saying that all of them, but I've tested a few. Most of the locks would be just, we'll get to that later, download some generic BLE application scanner, send data to the lock, try to open it, or any other method that we'll see later. But you can see now BLE devices everywhere, so it's medical equipment. I don't have to elaborate on that, but just imagine that you have, and these products are real, so imagine that you have some insulin patch on yourself, and with the app you can inject medicine to your body. So if someone hacks that, yeah, that's going to be great. Okay, so let's shortly review the architecture of BLE. It is based on 3 layers. Controller, where all the actual controls are there. So physical layer, all the chips, etc. And the interface for the host. The host is actually providing the API for the controllers, so we will be able to use them. And then there it's hold also the infrastructure, which holds the security manager and other security controls, and we will get to that. And the let's call it the interface for the app layer. So eventually we want to build apps that will be able to communicate with the devices. So these apps are built on top on the host and are using the specification that the host provides them. Okay, the security manager is the part in the BLE that is in charge of the security of the device. So it's in charge of the pairing process, which we will get to that, and the key generation and the key exchange and the other crypto features. It has AES 128 capabilities. It uses different types of key distribution. So here I'm going to distinguish that this talk is going to discuss BLE 4.0, which is the most current used protocol or version of the protocol. A more secure protocol was already implemented. It's BLE 4.1 and 5, which is just now getting out. And so it is already proved that the key exchange of 4.0 is not secured. We're not going to discuss that. You can see talks from Mike Ryan and other great talks that demonstrated how you can hack the connection link between of Bluetooth Smart, Bluetooth 4.0. And the pairing process, which uses a key to determine the connection link that will then encrypt the layer, the communication layer. So the first thing that you want to do when you try to, or that you are doing that when you try to connect your app to your device, is to pair to the device. Hopefully, I already seen many devices that doesn't even use the pairing. That means that you can just connect to them. So no pairing, you can just scan them, read data, send data, etc. So the pairing is a three-phase process. Pairing feature exchange, then short or long-term key generation, depends on the protocol, and the transport of the key. I'm going to shortly review it, and then we'll get to the interesting application layer. Sorry. Okay. So the first step when you want to connect to a device is that the device, let's say that we have an application that is going to talk to a Bluetooth device, and so they exchange capabilities. What is the capabilities? Is that each device has different capabilities of pairing, and we'll see 3 types of capabilities in a second. After they decided which or what is the preferred capability of each, or let's say pairing method that they can support, they initiate the pairing process. So the second phase is that the master, which is the hosting device, is generating a short-term key. The short-term key is derived from the pin that is part of the pairing method. And then after they determine the short-term key, they generate the key, and then they, on phase 3, then they distribute it between the devices so they can continue to communicate over a secured link. Okay, so how does that key is determined? There are 3 main methods of pairing methods between the device and the application. The first one is just works. Great name. The fact that it just works is because the key is a bunch of zeros. Okay. This is actually, it sounds funny, but this is actually, I'd say about 90% of the devices use that. Why? Because most of the devices don't have a screen to show you another PIN code, or even if they do, they prefer not to. So this is the most common method, really insecure. The second one is a 6-digit PIN. You might seen it maybe when you're trying to connect to your car. Then you have the nice multimedia screen, and when you want to connect, it presents 6 digits PIN code where you need to enter on your phone, and then you can connect to it. Okay, still 6 digits, 1 million options, still brute force. We can still brute force that. Again, we're not going to go into that. And the third method is out of band. Out of band means actually using a different way of key exchange. So that requires the device to have another way of communicating the key. It would have been secure if the device will also have, let's say, NFC to exchange a key over a different medium or over a different protocol. But that doesn't happen because Bluetooth devices have Bluetooth protocols only, or Bluetooth chips, so they can only communicate over Bluetooth. So I never actually seen that. Okay, it's in the specification, but of the protocol, but I haven't seen that, and I've tested a few hundreds devices, and I never seen that. Okay, so actually, if you go to the documentation, it says that word by word, none of the pairing method provide protection against passive eavesdropper. That's great. What were you thinking when you were creating this protocol? Oh, okay, don't worry, because the future version will implement Diffie-Hellman key exchange. That's very great of you, but I already bought the device. What will I do now? Okay, so I'm left with an insecure device and with no way of protecting it. Sorry. Okay, so is it secure or not in practice? I'd say that most of the devices doesn't use any type of encryption or any type of protection, just like any other applications that you're going to use or any other technology, they just come insecure. People don't bother of implementing security, of course, not security people, but when we go to developers, they don't do that. Why do they don't do that? As always, it comes in way behind the priorities and schedule. But there are other reasons as well. One of them is that sometimes there are different users or different apps that needs to communicate with the device. Sometimes the devices are public, some terminals or I don't know what, let's say a cashier or some of a kind. And of course, sometimes security doesn't come hand in hand with the requirements or the capabilities, etc. But mostly it's lazy developers. Okay, so security, in IoT is like everywhere else, security not always implemented. Okay, so we're going to discuss not the protocol layer, and we're going to see actually how we're going to use the application layer or the communication layer to hack the device, let's say, or the mobile application that is communicating with the device. To understand that, we need to understand the generic attribute profile. So each BLE device needs to implement, according to the specification, some kind of, it's called generic attribute profile, or in short, GATT. You can barely see the green titles. So these, let's say, requirements specify the services and characteristics and means or type of data that the device is going to serve. So if it's, of course, if it's a phone or a smartwatch, and you have other features like emails, etc. So you need to be able to communicate with it. So how the app knows what type of data to send, which service to connect to. So this all is defined in the characteristics and of the GATT. Okay, so you have a service. It has its description. So is it a battery service, or maybe it's a notification service, etc. What are the properties that this service serves? So you can read from it, you can write to it, and you can register to it. It's called notification, where you register to a service and then you keep getting information. Okay, and then for each service, this is how it's how the application knows how to communicate with the device. Typical flow of the Bluetooth communication. So BLE is because it's so power efficient and low cost and doesn't require much battery, it's continuously advertising itself. So if I want to communicate, to connect to a device, here I have a smart watch, we'll see later how we interact with it. Then, well, I'll say it's not that smart, but it's called that way. So it continuously advertises itself. So, hello everyone, I'm here. If you want to connect to it, to me, this is my ID. And when we want to connect to it, we just scan for Bluetooth devices on our mobile app. And then when we see the device that we want to connect to, we just click on it. They're exchanging and trying to pair or bond, depends on the capabilities of the device. And then after they establish the communication link, they start send data over it. Okay, so how do we know? Let's say I just found a device I want to connect to. I don't know what it is. I want to know what I can do with it or how I can connect to it. So I can do something like that calls discovering services. So after I connect to it, I ask the device to give me all the services and characteristics of its services so I can communicate with it. So here, for example, you can see a default, just a scanner, BLE scanner. It's a generic app you can download from the market. It works on all the type of devices, and you can just connect to any device. Of course, if no further security is implemented, and then start reading or data or writing data to it. So let's see just a short example of how it works. Okay. Okay, so this is the phone I'm going to use. Okay, so I downloaded, I don't know if you can see here, there are many generic BLE scanners, just the most generic of them. BLE scanner, it's called. Okay, of course I need to enable BLE Bluetooth on the device. And then I'll start to scan. There are many devices here. Okay. Yeah, I haven't seen that many anywhere. So I'll just see what happens when I go to the first one. Okay, you can see it says discovering services, and then I can start reading from it. So let's see what device is it. If you recognize it, don't worry. Not going to do anything. Okay, it's an Apple device. iPhone 8.4. Yeah, I narrowed it down. Okay, other services. Okay, so I can start reading these values. They're represented in hex. I don't really know what they are, but it's not that hard to understand what they are. Okay, so this is the battery level. Let's see if I can read that. No information. Okay, and then there are many custom services which are not the generic of all the devices, but specific for these devices. And here you can see that I can try to read. I'm not necessarily going to succeed. Sometimes they require some bonding or pairing, but not always. And I can also write data. So I can just send data to one of them. I'm not going to do that because I don't know what's going to happen and don't want to ruin your devices. So, but okay, so I have all this information. These are really some GUID IDs. I don't know what they do. How the hell do I need to understand what I need to do with them? So first, if it's an iPhone, I can just try using my own device and see what they do. And then when I want to do that on someone else, I already know what they are. And the second is that the protocol provides this. It's not just invented. Okay, so this is part of the protocol specification. So if I'm going to take this ID, at least the first part of the ID, or the first part of the ID, and then I'm going to look on it, for it on the on the Bluetooth website. Then I can see what these IDs actually mean. So I can see that battery services start with 180F, and I can see that cycling power is 1818, etc., etc. So I can assume, or I can start to understand what these services are. Of course, this requires some type of reversing, or how you want to call it. But the thing is that in many cases, these services are open for everyone to just connect to them, read data, or even worse, send data to the device. And they are just waiting for any device or any application to connect to it. Okay, basic BLE commands that we need to know. Okay, there are a few tools that you can that are built in the environment. Of course, after you install all the BLE libraries, HCI config, where you can configure your interface. HCI tool has many functionalities. To scan devices, you use LE scan, and HCI dump, which gives you a dump of the communication over a specific interface. These are examples. So, 1 second. Okay, I'll get to it in a second. Okay, there is another tool. Wow, you can't really see. It's called GAT tool. GAT from the generic attribute. And it actually lets you communicate with command line with the device. So GAT tool, you set the device MAC address. You can't really see that. Later, the presentation will be uploaded and you can see. And then you can connect to it, scan the services. So here you can see whatever we saw on the BLE scanner, all the services and their UIDs. And then I can just read these values, or I can try to write to them. Okay, this is regular communication between with the device using command line. Okay, but this is not what we hear. Okay, of course we can connect to them, but we want to see how we can set them in the middle. Okay, so why regular man in the, why is it interesting? Because regular man in the middle, the traditional man in the middle, is not going to work here. The traditional man in the middle, we stand in the middle between the application and device, and then send playing both roles for each other. So we're going to play the server or the device to the user, and then vice versa. But in this case, it's not going to work. Why is it not going to work? Because BLE, as a protocol, can only serve one purpose. So if this device is connected to some application, you won't be able to communicate with it further. So anyone tries to scan this device will not find it if it's already connected to the app. Okay, so it can only once it's connected, it cannot communicate over BLE. So if I'm here using Bluetooth and I'm connected to the device, I can no longer connect with the other side. Okay, so this sets the limitation for the original traditional man in the middle. So what we need to do is to have two components, or two black men in the middle. Yeah, that going to serve the other side for each other. So we're going to have one Bluetooth device. One Bluetooth device here going to connect to the actual device and serve as the client or the mobile app, let's say, and the other BLE device dongle that is going to connect to the app and going to serve as the device. Now, how they are going to connect with each other if they cannot use BLE? We need to use a different protocol. That's great. We can use any other protocol. For example, WebSocket. WebSocket would be really easy in that case. So what we are going to do is to use two BLE components to connect to the actual BLE devices, and then use the man in the middle over a WebSocket. This gives us the ability to perform an actual man in the middle between the device and the mobile. Okay, how we are going to do that? Very easy. So I've got here two dongles. They are really small, you're not going to see them, but you can buy them on AliExpress in $1.99. So they are very cheap. Actually, it can work with one device, but it is not that stable. So easy, spend $2 more, and then it would be much easier. So we have these devices, or let's say dongles or adapters, and then we're going to use two different VMs that are going to serve as both parties. So I downloaded Kali Linux, which comes ready, or not really ready, but with a lot of tools that I'm going to use later, and then I only needed to install some additional tools and libraries. And then I cloned this VM, so I have two VMs, and then what I'm going to do is, let's try to do that. Okay, so I have one device. Second. Okay, so I'm going to connect this BLE. Take into consideration that everything here bought on AliExpress, so they don't really work that well, but they work eventually. So I just connected them to the computer. Now I'm going to use to connect them to the VM. Okay, so I'm going to connect one of them to this VM. Okay, I can see that the interface is here. We just need to raise it. Yeah, up and running. Let's see that it works. So great, so it works. Okay, other VM. I'm going to connect the other BLE device or adapter. Yeah, great. Okay, so I connected each of the adapter to each of the devices, so to the VMs. Okay, so now I'm going to use a tool written by Slavomir, which I mentioned earlier. Really great tool. It's called Gattacker. Yeah, Gattacker, and it allows us to perform man in the middle. The same architecture as I showed earlier. Two components communicating with each other over WebSocket. Okay, so let's start. Okay, so I'm running one. So the slave is going to be here, and then let's start. Node scan. Okay, and then you can see that I scan a lot of devices. What I'm doing here, what the scan does here, is that it scans all the BLE devices that you can reach, and then stores their advertisement. The advertisement file is the name and properties of the device, the one that shows the name of the device, basically, and the version, etc. And then it stores it locally in the computer. And then now I have the advertisement file. The advertisement file is just the one that is advertising itself. So when you scan, these devices keep advertising itself. Okay, this is the file. So what I'm going to do is I'm going to play or to mimic this behavior from my VM, so that when an application wants to connect to the device, it will see my advertisement first. Why will it connect to my computer and not to the original device? Because I will already connect to it, so it will not be able to advertise itself anymore. Okay. So once I connect to the device, it is off limit of any other application wants to communicate with it, but my other VM, will publish itself as if it was the device. So now I want to scan the services and properties of the device. Okay. So I'm just going to use. I need the MAC address of the device. Okay, let's do something else. Okay. Sorry. Okay, and services file saved. Services file is what I showed you earlier, all the properties, custom services, battery services, etc. So now I have everything that I need to mimic the behavior of the device. So what I'm going to do now is node advertise, and then use these files that I stored when I scan them. And the services. Okay. I hope it works. Now what happened is that this tool connected to the device. Now comes the other party. Okay. Yeah. Okay, so when I bought this device, I've been told go to the market and download this power sensor app, which has all the capabilities that work with the device. So services, basically it's like a sport bracelet, so it can count your calories and measure the time and how many push-ups you're doing, etc. So I'm going to use this app to scan for the device. Okay, now I can see that the power watch here. I can see two power watches. 1 second. It's because it's disconnected. Okay. Yeah, I can see the power watch, and when I connect to it, I actually connect to the VM. So now this VM is actually man in the middle between the device and the mobile. So, but one thing to mention, we can see here, well, I can see, you cannot really see that, but it specifies the MAC address of the device. So basically, how does devices remember who they are talking to or who they have been talking to is according to their MAC address. Okay, so of course, if I'm going to present a false or different MAC address when I'm doing the man in the middle, then one of them can get suspicious and say, wait, how can it be a different device? How does the MAC address change? So what I will have to do, which is kind of easy, is do MAC spoofing. This tool also provides that, but that requires some reset of the Bluetooth. So to save time, I'm not going to do that. And then I'm going to use the same, just let the device connect to a different MAC address. Okay, so we can see that this device keeps sending data to the mobile app. We don't really know yet what they are, but if we go to the activity, you don't see that. A second. Let's put that here. And then that here. A second. Sorry. Okay. So I'm just going to jump rope. Okay, so I press play here. And here, of course, I need to jump. Okay, so when I jump, you can see the values are here. And then you can see that it actually counts my number of jumps. Yeah, okay, so this is the regular behavior. Now I want to modify this behavior. So what I need to do is hook to this service and then run a script that modifies it in the middle. So I already done that, but okay, so this is the function, the short script that is a threadmill hook. That basically what I did here is that I told him every time that you see these values in the data, in the communication, these are hex values, just add or replace the last two zeros with ones. Okay, simple hook. Okay, now it's not going to work because this device is already connected. So 1 second. Okay, so of course I'm going to do that in the beginning because I messed with it. Okay. Okay, so now I pre-hooked the threadmill activity. Okay, so I'm now going to run, but what I don't show you. Oh, that. I run really fast. Okay, and then I just do, of course, in this case, no harm was really made, nor for the device or to the mobile app, but it's working here on this sport device. It might work on more critical devices, critical or in terms of security or medical, etc. Okay, so it keeps counting, but I just add a few, modified a few bits there, and modified the data. Okay, so this is less interesting actually. The more interesting is that in addition, because we all love selfies so much, then this device, no, because you're going to use it to run in many cases. So this device also allows me to take pictures. And then is where the part where it gets, interesting. So if you don't want to be on the picture, it's the time to cover yourself. Yeah. And then I'm going to, okay, I'll flip that later. One second, some coordination. Opa, and I took the picture. Don't know if you can see that, but every time I click, I take a picture. Okay, so of course, now it becomes more interesting. What, I'm going to change the data? No, in this case, I'm not going to change the data, so I'm going to use a different tool now. Although now the newest version of Gattacker also supports replay attack. I'm going to show another great tool. Yeah, okay. It's called Beetlejuice. We're very creative with the names. Okay. Yeah. Oh, I forgot to mention. I'm not going to show that because I see that I'm short in time. But so WebSockets, really easy to use Burp because Burp supports WebSockets. So all we need to do is traffic the communication from the computer to Burp, and then route it to the device, and then we can use the WebSocket feature of Burp to just modify the data in runtime. Okay, so instead of hooking to the data, we can just modifying each request at a time. Okay, so back to Beetlejuice. Yeah, great. Okay, Beetlejuice also has a web interface. So now I need to select the target. Let's see that the device is on. Yeah. Okay, just light it up. Let's hope I can find it. Wow. Okay. There it is. Okay, so this app, now it's doing the same, it's discovering the services. It didn't connect, 1 second, and copying the services and publishing it by itself. Come on, you can do it. Last try, if not, I'm going to prepare the video, of course. Real bummer. Okay. That was the more interesting part. Let's see. Last try. No. Okay. So I'm going to move to the backup plan and show you the video. Okay, camera replay attack. We don't need the preparation. Okay, so I'm going to select the same watch and then connect to it. Now, every time I'm going to click and start the camera here, it's going to send a request, and you can see here the data here. And then with this tool, yeah, so I don't have to be on the camera to start the camera. And then I take the picture, and I can see the request here. Let's call it request, okay? The data here. And then I can simply select one of them, right-click and replay it. And then every time I'm going to click the picture, it's going to take a picture on the device. So I don't have to be there. I can just start. Once I have this let's call it request, I can start taking pictures on your phone. And it doesn't end with pictures, because the device also allows to play music on the phone. So I can also, let's see if I have that. Yeah, so do we have audio if I connect? Let's try. Probably going to make a lot of noise. No. Does it work? Okay, you'll have to imagine that visualized. So you can see that when I sent it, it started the music, so I can start playing. Don't know if you can see, but the songs are going to change here, and I don't have to be on the app to be to do that. So once I have that, if I'm sitting in the next room and someone is now presenting his talk, I can start his music on the phone from the room nearby. Okay, so you can see that every time I click the notify here, it changed the band here, or the song here. And I can start and stop. I'm sorry that the live demo didn't work. Okay, 10 minutes. Okay, so I'm going to wrap up. So we've seen Gattacker. Yeah. Okay, so we've seen Gattacker, a great tool by Slawomir, which allows us to hook to devices, and also in the newer version allows us to replay, to perform the replay attack. We can also use it to use burp, so we can just route the data to our computer to burp, and then modify the data in real time. And then we saw Beetlejuice, which has a nice web interface. Doesn't also always work, but when it does, it's great, and it's is one click from replay attack. Okay, so we saw that it's not secure. What can we do? Well, if we're using insecure protocol, then we are left on the application side to protect. Of course, on both sides, we need to not rely on the data, perform input validation if we can, and most importantly, enforce some access control, so the device cannot just connect to anyone. We can use a token on the first connection, so the first time we have to click, let's say, on a button, then they bond the pair for the first time, then we store a token, and then without this token or without resetting the device, we cannot further communicate it. But most importantly, as always, encrypt, sign, verify. These possibilities are provided by the protocol, even 4.0, but they are not used. So do that. And we're 7 minutes from finish. So one last word. So I told you I just moved to Trento recently. Sorry, but I have to. We're going to launch a B-Sides event in Trento. It's not going to be that big, but hopefully it's going to be nice. We're going to have some workshops and capture the flag. Maybe not as cool as the ones Jordan showed us earlier, but hopefully it's going to be fun. It's going to be in November this year. Stay tuned. We're just starting now, launching it now. So you can follow us on our website, or on our Twitter handle. And that's it. Thank you very much. Thank you for coming. Most of you are still awake. That's good. And enjoy the conference, the rest of the conference. Thank you very much. Questions?
Thank you very much. Yeah, we still have a few minutes for questions.
Yeah.
So you said earlier that you had to have two separate devices because it was using one side was the slave, the other was the master.
Yeah.
So you could not connect directly and do a man in the middle.
Right.
So my question is, if the device is already connected to some other thing, you could not do any man in the middle because you will have to kind of do the same thing as we do with Wi-Fi, which is de-authenticate, like do a de-auth attack and then rebind.
Yeah, well, if they are on the state that they are already connected to each other, you would have to cause them to deconnect and then reconnect.
And how would you do that?
Okay, so there are a few methods. Okay, so first of all, they're not always connected to each other because in order to not consume all the power, once they are not in reach, they are going to disconnect. You can wait for that time period. But there are also methods of causing them to deconnect. There are a few methods you can jam. You can start, I don't know, broadcast really strong with your with more devices, more adapters, and let the device connect to you, confuse instead of the original device. But yeah, you would have to cause them to deconnect from each other.
Any other questions?
Thank you very much.
Okay, thank you very much.